Happy day. This is Angayarkanni, Department of Computer Science, M.O.P. Vaishnav College for Women. Today we will see how an expression is evaluated by a computer system. An expression is not evaluated as it is first converted to postfix form and then evaluated. We will see how this procedure is carried out. An arithmetic expression is a combination of operands and operators. Operands may be constant, variable or arithmetic expression. Operator consists of plus, minus, multiplication, division, exponent and special characters like left parenthesis and right parenthesis. Expression can be categorized as infix, prefix and postfix expression. An infix expression is one in which two operands are combined by an operator in between. For example, here a plus b is an infix expression where a and b are operands and plus is an operator. Prefix expression is one in which the operator precedes two operands. Plus ab is an example of prefix expression. A postfix expression is one in which two operands, operator follows two operand. Example a b plus, here a and b are operands and plus is an operator. To evaluate an infix expression, you need to know the priority of operators. The priority goes like this. First priority is given to parenthesis, second priority is given to exponent, third priority goes to multiplication and division. Multiplication, suppose both multiplication and division appears on the expression, then the evaluation is in the order of left to right. Similarly, the fourth priority goes to plus and minus. Here also the order of evaluation is going to be from left to right in case both operators appears in the expression. Now we will see how an infix expression is converted to postfix. If a given expression is parenthesized, then the expression within parenthesis is evaluated first. If parentheses are nested, then the innermost parenthesis is evaluated. Here is an example of expressions with more than two operand. The first one is an infix form and the other two is the respective prefix and postfix form of the given infix expression. Now we will see what is Polish notation, reverse Polish notation and why we go for such notation. A prefix notation is called as Polish notation. This notation helps to pass the expression without ambiguity. Postfix expression is called as reverse Polish notation. If the expression is in infix form, operator precedence and parenthesis is used to evaluate it. But when using prefix and postfix notation, precedence and use of parenthesis are eliminated. The computer evaluates an arithmetic expression written in infix notation in two steps. First step, it converts the infix expression to postfix. In step 2, it evaluates the given postfix expression. For this, stack is used. Now we will see the algorithm to convert infix to postfix. Here the algorithm takes in as input a given infix expression and it is going to give as output a postfix expression. So the procedure is as follows. We will use a stack in order to convert the given infix to postfix. First of all, push a left parenthesis onto stack and add a right parenthesis to the end of the given infix expression. Now you have to start scanning the expression from left to right and repeat the following step. First, if an operand is encountered, just add it to the postfix expression. If a left parenthesis is encountered, please add it to a stack. If an operator is encountered, repeatedly pop from stack and add to the expression each operator which has a higher precedence or equal to precedence than the operator. After doing this, add the new operator onto the stack. Suppose if a right parenthesis is encountered, then repeatedly pop from stack all operators and add the operators to the given postfix expression until you encounter a left parenthesis. Now remove the left parenthesis but do not add it to the expression, just discard it. Now we will see how this is being done with an example. So to evaluate, the given expression is a plus b to the power of c minus d into e by f. So we are going to make use of a stack in order to do the conversion. First add a left parenthesis onto the stack and add a right parenthesis to your given infix expression as a sentinel value in order to indicate the end of the expression. Now we will start the procedure by scanning the expression from left to right. The first character to be scanned is left parenthesis, so push it onto the stack. Now the status of the stack after pushing the left parenthesis is shown. Continue this process. Scan the next element. The next element encountered as an operand A. So whenever an operand is encountered, you are supposed to add it to the postfix expression. So A is added to the postfix expression. Now scan for the next character. The next character to be scanned is an operator which is plus. Whenever an operator is encountered, just check the top of the stack for any operator with higher or equal to precedence. If you have any operator of higher or equal precedence, just pop it. Here we don't have any operator, so just add the new operator onto the stack. Now once again repeat the process. Scan for the next element. The next element encountered is an operand B. So whenever an operand is encountered, you are supposed to add it to the postfix expression. So B has been added to the postfix expression. Now continue the same process. Scan the next character. The next character to be scanned is a right parenthesis. So whenever a right parenthesis is encountered, repeatedly pop from stack all operators and add it to your given postfix expression. So plus is popped up and added to your postfix expression. After that, you have a left parenthesis, just pop it, but do not add it to your expression. Now continue the process. The next element to be encountered is an exponent. So check the stack for any operator with equal or higher precedence. There is no operator. So just push the new operator onto the stack. The status of the stack after pushing the new operator is available. Once again repeat the same process. Scan for the next element. The next element is an operand C. So add it to your postfix expression. Once again scan the expression for the next character. The next character to be encountered is a minus operator. So whenever an operator is encountered, check the stack for any operator with higher or equal to precedence. Yes, there is an operator exponent which is going to be of higher precedence than minus. So pop it out and add it to your expression. Now add the new operator onto the stack. So this is the status of the stack after adding minus operator. Once again, please continue with the same procedure. We are going to scan the expression from left to right. So the next element to be encountered is a left parenthesis. Whenever a left parenthesis is encountered, please add it onto the stack. So it has been added to the stack. Scan for the next character. The next character encounter is an operand D. So add it to your postfix expression. We have added it. Now if you see what is the postfix expression formed so far is A, B plus C to the power of D. Once again continue the same process. Scan for the next element. The next element encountered is an operator multiplication. So whenever an operator is encountered, check the top of the stack for any operator with higher or equal to precedence. Now if you see the stack, there is no operator, so add the new operator onto the stack. So operator multiplication has been added into the stack and this is the status of the stack now. Once again continue the same process. The next element to be scanned is an operand. Whenever an operand is encountered, add it to your postfix expression. So he has been added to the postfix expression. Scan for the next character. The next character is a right parenthesis. So whenever a right parenthesis is encountered, repeatedly pop all operators from the stack and add it to the postfix expression. So multiplication is popped out and added to your postfix expression. After that, there is a left parenthesis, pop it out and just discard it. Now continue the same process. The next element to be scanned is a division operator. So whenever an operator is encountered, check the stack for any operator with higher or equal to precedence. If you see at the stack, it has a minus operator, it has less precedence. So just add the new operator onto the stack. Now this is the status of the stack. The stack contains a left parenthesis, a minus operator and a division operator. Once again continue your process. Scan for the next character. The next character to be encountered is an operand F. So add it to your postfix expression. Now continue the process. The next element to be encountered is a right parenthesis. You know that whenever a right parenthesis is encountered, repeatedly pop all operators from the stack and add it to your postfix expression. So we will pop division operator added to the postfix expression. Pop minus operator added to the postfix expression. The next one is the left parenthesis, pop it out and just discard it. Now if you see the stack is empty, the empty stack shows that you have done your process. The given infix expression has been converted into postfix expression and we have got the resultant expression as A, B plus C to the power operator D, E, multiplication, F, division and subtraction operator. This slide shows a whole operation which has taken place and this is an example which has been given to you. You can solve it to know whether you have really understood the problem or not. Instead of making use of stack, the shortcut form has been listed here, but you can try using a stack. In today's session, we have seen how an expression is evaluated by a computer system. We have seen how to convert an infix into a postfix form and how and stack is being used for this purpose. Hope this session is useful to you. In the next session, we will see how to evaluate a converted postfix expression. Thank you.